Welcome to the fourth session of our second module in CFF, students. In the last class, we have studied how to write the different temperature ratios T star by T equal to some 2 by gamma plus 1 plus gamma minus 1 by gamma plus 1 into m square. Similarly, P star by P equal to same 2 by gamma plus 1 plus gamma minus 1 by gamma plus 1 m square is to gamma by gamma minus 1. The rho star by rho is equal to 2 by gamma plus 1 plus gamma minus 1 gamma plus 1 square 1 by gamma raised to minus 1. The students and one more A by A star also we have found. Area by A star. All the starter terms are nothing but critical the properties in the critical state or the throat condition, minimum area. 1 by m 2 by gamma plus 1 plus gamma minus 1 by gamma plus 1 m square gamma plus 1 by raised to gamma plus 1 by 2 raised to gamma plus 1. 2 raised to gamma minus 1. Okay, so this is the equation for A by A star. Students, the main point you have to understand is that T star by T T star by T is a function of now Mach number and gamma only. Similarly, P star by P equal to function of Mach number and gamma. Rho star by rho is a function of Mach number and gamma. And A by A star is also a function of Mach number by gamma. So this is function 1, function 2, function 3, function 4. So all these ratios, dimensionless ratios are made as a function of Mach number and gamma. So if you merely know the value of Mach number and gamma of the particular state, you can easily find the T star by T, P star by P, rho star by rho, A star by A by A star. All these ratios can be easily found if you know the value of Mach number and gamma and the equation. So students, now the important point is that all these ratios are tabulated in gas tables. Gas tables, you will get all the values. You need not by heart those equations, so you don't require equations to find these ratios. Use gas tables. I will show the gas tables. So students, this is the gas table. So here you can see the condense isentropic. The third section is isentropic flow of perfect gas for gamma equal to 1.4. Usually we use the value of gamma as 1.4 for air. So there are three different sections: gamma 1.3, 1.4, 1.67. So accordingly, according to the question, you select the table. So you can see here. So this is isentropic flow. So some data are already given in the data gas tables, like in isentropic flow of perfect gases. The graph or the figure HS diagram is here for accelerating flow and decelerating flow, and the equations we have derived is also here. So you don't need to by heart those equations. It is already available in gas tables. You just, if sometimes it may be asked to derive the equations, so you have to study the derivation only. You don't by heart the final equation. Okay, so all the equations are available in tables. Now we will move to the table. Okay, so here you can see the table of isentropic gas. Sorry, by the isentropic flow of perfect gas for gamma equal to 1.4. So here correspond. So gamma 1.4 and for different Mach number, the value of m star reference Mach number t by t0, p by p0, a by a star, f by f star, and a by a star into p by p0, all these values are given, right? So all these values are available. So you don't need to by heart all the equations, or you don't need to substitute the values in equation. All these values are tabulated in these gas tables. So you just need to pick the values. So you will get more understanding of these things while we are doing problem. So for the time being, you just understand that this is how things are done in problems. Okay. So here you see another term called f by f star, the ratio of impulse function. So we haven't derived the equation for f by f star. So we will try to derive that also. So impulse function ratio, impulse function ratio. Impulse function ratio, we know impulse function f has the equation we have already derived in the first module, p into a plus into 1 plus gamma m square, right? So what will be f star? F star is the value where area is minimum and m is 1, Mach number is 1. So p star, f star will be p star into a star into 1 plus gamma, because m will be equal to 1. So the impulse function ratio f will be pa into 1 plus gamma m square by p star a star 1 plus gamma, right? So we know p by p star, we know the value, and a by a star also we know the value. These values are already, we have derived the values for the equation for these things earlier. So substitute. So I think we have already know this, we know the value. So p star by p is not, so inverse of this, and s star, so this value is also known. Okay, so f by f star can be written as 2 by gamma plus 1 plus gamma minus 1 by gamma plus 1 m square minus gamma by gamma minus 1 into 1 by m 2 by gamma plus 1 plus gamma minus 1 by gamma plus 1 m square gamma plus 1 by 2 gamma minus 1 into, and the remaining part 1 plus gamma m square by 1 plus gamma. Okay, so this much thing. So if you continue to simplify this, you will get, you don't worry about the simplification. The final answer will be like this: 2 m f by f star is nothing but m 2 gamma plus 1 1 plus gamma minus 1 by 2 m square raised to half. So this is the equation for f by f star. So students, don't worry about the length, don't worry about the equation. This is 1 plus, okay. So you just understand this is a function of, again, Mach number and gamma only. So this value, if you know the value of Mach number and gamma, you can find this value for f by f star from table. Don't worry, it is already tabulated. So you just don't need to substitute the values in this equation. It is already available in that table. That thing you try to understand. Now very important, mass flux in terms of Mach number. So everything we are trying to find in terms of Mach number and gamma. So all the equations are made in the form of a function of Mach number and gamma. So that is the main aim. So here what is mass flux? Mass flux is nothing but what is uh, mass flow? Mass flow is m dot. M dot is nothing but rho AV. Mass flux is mass flow per area. So this is mass flux. Mass flux. So it will be rho into V. So rho V m dot by A is equal to rho V. Rho V can be written as rho is written as P by RT into velocity. If I am multiplying with gamma in numerator and denominator, it will become like this. So this gamma PV by gamma RT can be written as root gamma RT into root gamma RT, right? So root into root is gamma RT. Okay. So gamma P by gamma root gamma RT into V by root gamma RT. So what is this root of gamma RT means? Area, sorry, not area, acoustic velocity, right? So this is V by A. V by A is nothing but Mach number. So this will become Mach number. So m dot by A will be gamma P by gamma RT into m, right? Right. So this root gamma by root gamma is nothing but root gamma by root RT. Sorry, you can write it this. You can write like root gamma by R into P by root T into M. So I am changing like this. I'm slightly changing the arrangement like this. So the gamma in the numerator gets cancelled by root gamma. So root gamma remains. So this is how things look like. Now concentrate on this term. What is P by root T can be written as P by P0 into P0 by root T. Okay, I'm applying P0 in numerator and denominator. Now root T can be written as P by P0 into root T0 by root T into P0 by root T0. So I am applying root T0 in numerator and denominator. Right? Right? Okay. So I am substituting this in the previous equation. So here I am substituting for P by root T. So what will the equation become? M dot by A is equal to gamma by R, root of gamma by R into P by P0 into, P by P0 into root T0 by whole root T0 by T into P0 by root T0 into Mach number. So this is the equation. And now you can substitute for P by P0 and the root of T by T0, because these are stagnation values, right? So already we have already derived the equations for P by P0 and root of T by T0. So substitute those values. So what will be P by P0? P by P0 is nothing but 1 plus gamma by 1 plus gamma minus 1 by 2 max square. Gamma by minus gamma by gamma minus 1, because P0 by P is gamma minus 1. Okay, so be very careful with the equation. Okay, into And similarly, T0 by T is nothing but 1 plus gamma minus 1 by 2 max square. So root T0 by T means raised to half. So substituting these equations. So let this be 1. Okay. Let this equation be 1, 2, 3. Substitute 2 and 3 in 1. Gives m dot by a equal to root of gamma by r 1 plus gamma minus 1 by 2 max square gamma by 1 minus gamma. So minus I am taking it inside into 1 plus gamma minus 1 by 2 max square raised to half into P0 by root T0. So there is no equation for P0 by root T0 into M. So if you simplify it, you will get it as m dot by a equal to gamma by r into P0 by root T0 into m, and this will become 1 plus gamma minus 1 by 2 max square. So both the terms get clubbed to 1. So it will become 1 plus gamma by 2 into 1 minus gamma. So this is the equation for mass flux. Okay. So this equation shows that for a given local Mach number, the mass flux is proportional to the what? Mass flux is proportional to stagnation pressure, inversely proportional to square root of stagnation temperature. Okay, so this is directly proportional to P0 and inversely proportional to the square root of T0. So mass flow per unit area will be maximum at the section where flow area is minimum, right? The m dot A will be maximum, max when A is minimum, right? Whenever A becomes the minimum value, the m dot A will become maximum value because m dot is constant. M dot by A will be maximum when A will be minimum, right? So in order to find the condition for maximum minimum flux, what to do? If you have to find maxima, so what will you do? You just differentiate. So it depends upon Mach number only, right? It depends upon Mach number. So you differentiate with respect to Mach number, and it should be equal to 0. So you can find maximum value. How to differentiate? So you don't need to since P0 and T0 are constant, right? Are constant. They are stagnation condition or reservoir condition. It won't change. Only Mach number change. So that is why we are differentiating with respect to Mach number. So here d by dm of m dot a will be nothing but root gamma by r into P0 by root T0 into Mach number into 1 plus gamma minus 1 by 2 Mach square 1 plus gamma by 2 raised to 1 minus gamma, right? Is equal, it should be equal to 0. Since all these terms are constants and since we are equating with 0, you don't need to take these values. So it will be d by dm of Mach into 1 plus gamma minus 1 by 2 Mach square 1 plus gamma by 2 into 1 minus gamma. It should be equal to 0. So apply the product rule. Just try to apply the product rule. Okay, I am taking m as one term and this as another term. So m d by dm of m is 1. So 1 into 1 plus gamma minus 1 by 2 Mach square 1 plus gamma by 2 1 minus gamma plus now m into differential of the other term. Differential of the other term will be, so this is 1 plus gamma by 2 1 minus gamma. So x raised to d by dx of x raised to n means n into x raised to n minus 1. So that will become 1 plus gamma minus 1 by 2 max square 1 plus gamma by 2 1 minus gamma minus 1 into gamma minus 1 by 2. Okay, I will write once more. So there's no space here. Okay, I will write once more. 1 plus gamma minus 1 by 2 max square 1 plus gamma by 2 1 minus gamma. So this is first term plus max into, so x raised to n is nothing but differentiate d by dx of x raised to n is n into x raised to n minus 1, right? N into x raised to n minus 1. So that is I am applying here. So m into 1 plus, so this is the exponent 2 into 1 minus gamma into 1 plus gamma minus 1 by 2 max square into 1 plus gamma by 2 gamma minus 1 minus 1, right? Into, again we have to differentiate m square is here, right? So we have to differentiate m square also. So we have to apply the product rule, so the chain rule. Gamma minus 1 by 2 into m square, you will get 2m. So it will be equal to 0. Now we have to simplify it. Okay. So dividing throughout by the first term, and so you can divide with this term throughout. So what will happen? So I am dividing with this term throughout. So it will become 1 minus some m square. You just try to simplify m square. 1 plus gamma by 2 into 1 plus gamma minus 1 by 2 max square minus 1 is equal to 0. So this is the equation we are getting. And m square 1 plus gamma by 2 into 1 plus gamma minus 1 by 2 max square minus 1 will be equal to 1. I am taking the 1 to other side. This is m square, okay. Now since this is raised to minus 1, it means you can write m square 1 plus gamma by 2 into, okay, so here it is 2 plus gamma. I am taking this to here, 2 plus gamma minus 1. Can write it as like 2 by 2 plus gamma minus 1 by m square. Okay, now this 2 and 2 cancels, so it is equal to 1. M square 1 plus gamma by 2 plus gamma minus 1 by m into 1 square equal to 1. Okay, now you just cross multiply it. Cross multiplying, you will get m square 1 plus gamma equal to 2 into 2 plus gamma minus 1 into m square. M square plus gamma m square equal to 2 plus gamma m square minus m square. So this gamma m square cancels. So 2m square equal to 2 and m square equal to 1 you will get. So m means plus or minus 1. Plus or minus 1. Mach number at. So since Mach number can only be positive. M is always positive. So therefore m equal to 1. So what do you get? So m equal to 1 represent the condition for maximum mass flux. Maximum mass flux. So at minimum flow area section, Mach number is unity. So therefore, at minimum area, you will get Mach number equal to 1. So maximum mass flux is always at minimum area. So at minimum area, Mach number will be 1. That is what we have obtained. So this is how we write the Mach number at throat. Throat is the minimum area of flow. At throat, M is always equal to, at throat, M is equal to what? That is what we have obtained. Okay. So our equation for M dot A max will be root of gamma by R into P0 by root T0 into Mach into 1 plus gamma minus 1 by 2 Mach square 1 plus gamma into 2 1 minus gamma. So here you should substitute Mach equal to 1. Mach should be substituted 1. So this cancel, this will be 1. Okay, so you can write M dot A max will be M dot by A star, because A will be minimum. So the value of A can be written as critical A star equal to gamma by R into P0 by root T0 into gamma plus 1 by 2 into 1 plus gamma into 2 1 minus gamma. So this is the equation for maximum flux, maximum mass flux, max flux. Okay. So if you substitute R equal to 287 and gamma equal to 1.4 joule per kilogram Kelvin. So this is our air. If the fluid is air, you substitute those values here, R and gamma. Okay. You substitute for R and gamma, you will get M dot by A star as 0.0404 into P0 by root T0. So you don't know the value of stagnation conditions. So the equation get reduced to this one. Or you can also write M dot by A star into root T0 by P0 as 0.0404. So this is the equation for air. So this is always constant for air. Okay. So this result, which is derived from the theoretical equations obtained, is known as Fliner's equation. Fliner's equation. What is Fliner's equation? M dot by A star into T0 by P0 equal to 0.0404. So this equation is known as Fliner's equation. Okay. Students, some more concepts: flow coefficients and efficiency of diffuser and nozzle. So this now we are going to study these things. So students, for nozzle we can write the energy equation SFFE as H1 plus H1 plus V1 square by 2 is equal to H2 plus V2 square by 2, right? So V2 will be higher than V1, H1, so V2 will be higher, H1 will also be higher. So H1 is greater than H2, V2 will be greater than V1 in case of nozzle. So here H1 minus H2 can be written as V2 square by V1 square by 2, right? Okay. So this is since nozzle is always considered as isentropic. isentropic. So this is H1 minus H2 is nothing but isentropic heat drop or enthalpy drop. But in actual condition, if it is some sort of losses, it may not be reversible in actual condition. Actual case irreversible. Sometimes the process may be irreversible. So it won't be isentropic. It will be just adiabatic. So actual case you just notate it as H1 minus H2 dash. So H2 dash, it will be actual equal to C2 square minus C1 square. Okay, so this is the actual case. So actual velocity C2 will be different from, so in actual case I will show it. So in HS diagram you have already read. So this is our first pressure P1, this is second pressure P2. So this is our H1. Okay, H1 for 1 from the position 1. Let this be the position 1. Okay, now the actual case is the process may be isentropic 2. So this is H2. Okay, sorry, ideal case. This is ideal case. But in actual case, the process will be like this. It may not be isentropic in every sense. Due to some losses or irreversibility, it won't be isentropic. So this may be 2 dash. So corresponding to this H2 dash. Okay, this is H2 dash. So and the velocity here is V2, velocity here it is V2 dash. Okay, so that is why I'm introducing a term called efficiency, nozzle efficiency of nozzle. Eta n is nothing but H2, H1 minus H2 dash by H1 minus H2 or C2 dash square minus C1 dash square by C2 square minus C1 square. Okay, so this is the efficiency of nozzle. And one more term, coefficient of discharge of nozzle, that is CD nozzle, is equal to m dot actual. So the mass flow in the actual case by mass flow in the isentropic case, m dot n actual by m dot n isentropic. So it is defined as the ratio of actual mass flow rate due to the the ratio of actual mass flow rate to that due to isentropic case, the actual case by isentropic case. So here this is actual, this is isentropic. So that is difference. Okay, similarly in case of diffuser, how can you show it in the graph? So this is HS. So diffuser, this is P1, this is P2. So here it is 1. So we are expanding in diffuser. So it will be pressure is getting decrease. Sorry, pressure is getting. So we are contracting it. In diffuser we are reducing the speed. Okay, reducing the speed. So it will be in the upward direction. So this may be the actual isentropic. S is constant, but actual case it will be like this 2 dash. Okay, so this is H2 and this is H2 dash and this is H1. So in diffuser, H1 plus V1 square by 2 equal to H2 plus V2 square by 2, right? So H1 will be less than H2. V1 will be greater than V2. So we are reducing the velocity and increasing the pressure. Okay. So here H2 minus H1 equal to V2 square V1 square minus V2 square by 2. Okay. So this is isentropic case. So in actual case H2 dash minus H1. So this is actual case equal to V1 square minus V2 dash square by 2. Sorry, in this case it is not C, it is V. Okay. So we took the notation as V. So this is V2 dash square minus V1 square by V2 square minus V1 square. Okay. So the ratio, so we define ratio of discharge, ratio of diffuser as here. We have to take isentropic case higher. Isentropic case at in the numerator. So H2 minus H1 by H2 dash minus H1. This is isentropic by actual. Is equal to V1 square by V2 square by V1 square minus V2 dash square. So this is how define efficiency of diffuser. So students, you have to note that here it is actual. In case of nozzle, actual by isentropic, and in case of diffuser, isentropic by actual. Why? Because here in the numerator we are taking isentropic, because in the numerator isentropic is taken because isentropic value is lesser, actual value is higher. So in the numerator we take lower value. Here in the case of nozzle, this value is actual value is lower and the isentropic value is higher. So actual value is taken is in the numerator. So in order to make the value of efficiency less than 1, we will take the lower value in numerator. So that is that point you just remember. So in case of nozzle, it is like efficiency is like actual by isentropic. In case of diffuser, it is isentropic by actual. Okay, so that difference is there. You don't ever confuse with those things. Okay, you should be very clear and thorough. And here coefficient of discharge CD of diffuser is nothing but what will be it? It will be since mass of isentropic flow by mass dot in actual flow. So that will be the coefficient of discharge. So students, by this I am stopping this session. Thank you.